Hello everyone and welcome back to the GCSE Maths series. Today we're going to be taking a look at volume and area of similar shapes and their respective scale factors. So let's get straight into it. So if two shapes are similar, all of their corresponding lengths are in the same ratio k. The surface area then scales by a factor k squared. I believe we touched on this in the previous video on similar shapes, but we're going to take more. We're going to go into more detail in this video here. So we are told if two shapes are similar. These two shapes are similar, these two circles, and let's say this radius is 3 centimeters, but this radius is 6 centimeters. So this leads us to believe that the linear or the length scale factor is 2 because we're scaling by a factor 2. We're timesing by 2 to get from the smaller one to the larger one. Now, this is our value for k. When we're looking at the surface area or the area of the smaller shape compared to the larger shape, we notice that it scales by a factor of k squared. So in this case, it will scale by k, which is 2 squared. So it will scale by a factor of 4. And this is what I mentioned in the example. If the length of a square A is double the length of a square B, the area of A is 4 times larger. So let's say this is B and this is A. The length here is 6 and the length here is 12. So we can say that the length scale factor is times by 2. This means that the area scale factor is times by 2 squared, which is times by 4. So the area of this one, let's say it is 20 centimeters squared. This one will then be 80 centimeters squared because we use our scale factor of 4 to get from the smaller one to the larger one. Okay, now let's look at some questions. So it tells us that a surface area of a small sphere is 72 pi centimeters squared. A similar larger sphere has a radius 2.5 times bigger. So we're looking at a sphere and we are told that the larger sphere has a radius 2.5 times larger. And this is our length scale factor, remember guys. So we need to find the surface area of the larger sphere. So if k is equal to 2.5, then our area scale factor is equal to 2.5 squared. 2.5 squared is equal to 6.25. So we need to times our smaller surface area by 6.25 to get our larger surface area. So we do our small surface area of 72 pi times by 6.25. And this is going to get us an answer of 400. Wait, no, let's put this in properly. We're going to get an answer of 450 pi. And that is the area of our larger sphere. So, looking at question 2, it tells us two similar circles have radii in the ratio 5 to 3. And this is to do with our length, our radius. What is the ratio of their areas? So the way we do this is we look at our k ratio. Our k ratio is 5 to 3. Then our area ratio would be 5 squared to 3 squared, which is going to be our k squared ratio. And this simplifies to 25 to 9. And that is our answer. Okay, now looking at volume scale factor. If two shapes are described as being similar, all corresponding lengths are in the same ratio k. The volume then scales by a factor k3. So if we have the length of a square A and say it is 2 centimeters, and we have our 4 centimeters in square A and 2 centimeters in our square B, our length scale factor is equal to times by 2. Now our area scale factor would be times by 2 squared, as we mentioned in the previous slides, which is times by 4. our volume scale factor will be equal to times by 2 cubed, which is times by 8. So say the volume here is equal to 16 centimeters cubed. Our volume here would be equal to 16 times by 8, which is equal to 128 centimeters cubed. Okay, looking at this, a small cone has a volume of 50 centimeters cubed. So we have our small cone here, and the volume equals to 50 centimeters cubed. A similar larger cone has a linear scale factor of 3, so K equals to 3, and this is our larger cone. Find the volume of the larger cone. So we have our K equal to 3, our K squared, which is our area scale factor, is equal to 3 squared, which is equal to 9. Our volume scale factor is equal to K3, which is equal to 3 cubed, which is equal to 27. Therefore, our scale factor for the volume is timesing by 27. So looking at our smaller one, we do 50 times by 27 to equal our larger volume, which is equal to 1350 centimeters cubed. Okay, the volume of a small pyramid is 125 centimeters cubed. So volume is equal to 125 centimeters cubed. We have, let's say, that's a pyramid, yep. So a similar larger pyramid has a surface area 4 times greater than the smaller one. So this tells us that we have our larger one, which looks something like this. That is our larger pyramid, and it has a surface area 4 times greater than the smaller one. So the surface area scale factor is equal to times by 4. Now we need to work backwards in this case to work out our original case, so our length scale factor. So what we do is we square root our 4 to get the length scale factor to times by 2. Then we look at our volume scale factor and we do 2 cubed, which is equal to 8. That is our volume scale factor. So to work out our volume of the larger pyramid, we do 125 centimeters cubed times by 8. So 125 times by 8 gives us 1000 centimeters cubed. Okay, that's going to conclude today's video on volume and surface area of similar shapes. As always, please make sure to like, comment, and subscribe, and I'll catch you guys in the next video. Peace.